after studying this module, you would be able to know about aggregate demand, you would be able to derive the aggregate demand function, understand about the shape and slope of the aggregate demand function, and understand about demand management. Let us now consider the aggregate demand function. In an ordinary market situation, in a micro market, when we talk about the demand cross, there we find that the demand function intersects the supply function. But if we compare this situation with the aggregate demand and aggregate supply in a macroeconomic market, which is the product market, then there is a vast difference, because when we consider the aggregate demand and supply, then on the x axis we do not have quantity demanded, we have output, and on the y axis we do not have the price, that is the relative price of an individual commodity, but we have the general price level. Thirdly, the aggregate demand and supply in the economy is based on the ISLM framework and is derived from it. Now, the implications are that in the Keynesian system, the before full employment, there was no role of the prices, whereas in the classical system, the price level was all important, and full employment level of output was assumed to be constant. So, these two systems were not compatible with each other. Now, the modern aggregate demand function is a function which is sensitive to the price level. Therefore, the policy implication is that if we talk about demand management, as we will be speaking in a little while, then demand management has to take into account the inflation and the impact and implications of the general price level. Therefore, there is a need to derive an aggregate demand function that is sensitive to the general price level. Now, let us consider the derivation through the graphical method. Here, what we do is that, as you would see in the diagram, we have a 4-quadrant diagram, but to make it more explanatory, we have also included a 5th quadrant. On the y axis, we are measuring the rate of interest. In the first quadrant, we have the LM function, and the LM function relates the rate of interest to the level of income or real output. So, in the first quadrant, we have on the y axis we have rate of interest, and on the x axis we have real output. And as you would see, there is an original LM function called LM, which is based on P0, which is the existing price level, and it is given in bracket as LM bracket P0. And at this point, what we see is that the IS curve intersects the existing LM function, and the equilibrium rate of interest is R0 and the equilibrium level of income is Y0. At Y0, given the ky function, which is the function which tells us about transactions and precautionary demand for money, there is a given level of M1. In the third quadrant, you would see that there is a money supply function which is given by M bar upon P0, and in the third quadrant we are actually looking at the money market equilibrium. the money market equilibrium would ensure that the money supply, the supply of real cash balances would be equal to the demand for real cash balances, which are being measured on the negative x axis in the second quadrant. Now, given the level of M1, the balance of the money supply would be absorbed by M2, which is speculative demand for money. Speculative demand for money depends upon the rate of interest. Therefore, at the given rate of interest R 0, the M2 would be exactly equal to the excess of money supply over and above the M1, which is a function of Y0 at the given level of income Y0. Therefore, we have completed the equation between the equilibrium rate of interest and the equilibrium level of income. Now, let us consider a new money supply function. The supply of real cash balances now in the third quadrant is M bar upon P1, okay, and P1 represents a lower level of prices in the economy. So, when price level goes down and the nominal money supply is the same, it is M bar. And so, what happens is that the supply of real cash balances goes up, and accordingly, if we look at a new situation where the LM function has expanded, so in this new situation the LM is now LM within brackets P1, which is a lower level of the price in the economy, and so we have now a new rate of interest R1 and we have a new level of income Y1. So, the new intersection between the existing IS function and the new LM function LMP1 results in a new equilibrium rate of interest and a new equilibrium level of income. So, these are all this is the background dynamics that we understand that is taking place in the economy by the interaction of the money market and the product market. As a result, what has happened is, when the price level has fallen from P0 to P1, the rate of interest has gone down and consequently the level of income has increased from Y0 to Y1. Now, if we were to extend the dotted line from Y0 and Y1 respectively down into the fifth quadrant. Now, in the fifth quadrant, on the x axis we have output or production, or you could call it aggregate demand. In equilibrium it would be aggregate demand, and on the y axis in the fifth quadrant we have price level. P0 is a higher price level and P1 is a lower price level. So, what is happening is, corresponding to the decline in the price level in the economy, the aggregate demand has expanded from Y0 to Y1. Hence, at price level P0, the aggregate demand is Y0, at price level P1, which is a lower price level, the aggregate demand is Y1. So, this shows us that the aggregate demand function is downward sloping. However, it is also important to see that how could we derive this with the help of a little bit of algebra. Aggregate demand, as we know, is equal to C plus I, and within the consumption function we have an autonomous part which is C bar plus small c by, small c is the marginal propensity to consume, and the autonomous investment also. Accordingly, we have a fixed amount of autonomous investment which is I bar. This is equation number 2a. Now, if we combine these two equations, that is, the first equation is of aggregate demand and the second equation is of the consumption function, then aggregate demand function could be described as C bar plus small c y plus I bar. And if we consider the equilibrium in the product market, it shows that aggregate demand is equal to aggregate supply. This is equation number 4. Now, if aggregate supply is nothing but the level of output or income in the economy, therefore y is equal to, now what we are doing over here in equation 4a is that we are putting the autonomous part together, C bar plus I bar, and then the induced part, which is small c y, which is the consumption, induced consumption is taken separately. Therefore, the equation can be rewritten as y is equal to A bar plus small c y. This is equation 4b. Okay. So, if we consider this equation for a particular level of income y0, then it would read as y0 is equal to A bar plus small c y 0. This is the income determination equation, and if this is transformed, it can be read as in equation number 6, y0 is equal to A bar upon 1 upon minus small c. Small c is the marginal propensity to consume. So, now this represents the product market equilibrium. In the asset market, the money supply is given and the price level is also given. Therefore, the supply of real cash balances is m bar upon p, equation number 7a, and the money demand is a function of income and rate of interest. Therefore, money demand is equal to ky minus hi. H is the interest sensitivity of money supply and k is the income sensitivity of money supply, or the proportion of cash balances held for transactions and precautionary purposes. In the money market, the equation is money supply is equal to money demand, and therefore, money supply being m bar upon p, supply of real cash balances, would be equal to ky minus hi. This is the equilibrium, overall equilibrium in the money market. This is equation number 9. If we transform this, then we get I is equal to 1 upon h whole bracket ky minus m bar upon p bracket closed, and this is equation number 10, and this is the interest determining equation, or you could call it the LM function. So, now we also have to consider what happens to investment. Investment also has an autonomous part I bar minus bi, which is the b is the sensitivity of investment towards rate of interest. Okay. Now, if we combine the aggregate demand equation, then it reads as y is equal to C bar plus I bar plus small c bar. Now, why are we considering small c bar? That is, if we consider disposable income, then small c would not remain small c, but it would be represented as small c bar into y minus bi. Okay? And if we look at the equation in the product market, y represents aggregate supply, it is equal to aggregate demand, and simplifying equation number 11, we say it is A bar plus small c bar into y minus bi. So, at y0, once again we can rewrite this equation as it has been shown in equation 12a. Now, this can be transformed as was done in the earlier case for a particular level of income. This is equation number 13. This tells us about the equilibrium in the product market when we have disposable income, that is including the impact of taxes. Now, let us introduce government expenditure. y0 is equal to alpha g into bracket A bar minus bi bracket closed, and so this is equation number 14. As we know that alpha g is the multiplier of government expenditure multiplier, and it is equal to 1 upon 1 minus c bar. it is exactly the same as the Keynesian investment multiplier. We have seen earlier that the LM equation is that I is equal to 1 upon h ky minus m bar upon p. Okay? And from equation number 14 and 15, if we combine the two, then y is equal to alpha g square bracket a bar minus b by h, then round bracket, normal bracket ky minus m bar upon p, ordinary bracket close, square bracket close. This is the equation number 16, which is a derivation from the intersection or interaction of the LM function and the IS function. Now let us further simplify it by taking the the parameters onto one side. We arrive at equation number 16a, and there are various steps 16a, 16b, and then finally we arrive at equation number 17. And you would notice that in equation number 17, the interesting part is basically y is on the left hand side, then there are a whole lot of parameters like alpha g divided by 1 upon k alpha, and then you have a square bracket in which you have a bar, which is the autonomous expenditure, and then we have b by h, which again are two parameters, and in brackets we have the supply, money supply, that is m bar upon p. Now we are able to see that there are three things over here. We on the right hand side we have money supply, on the left hand side we have output, and then these are related with the help of a number of parameters and autonomous expenditure. If this is further simplified by specifying that gamma is equal to alpha g upon 1 plus k alpha into alpha g into b by h. This entire expression can further be simplified, and in equation, this was equation 17a. Now in equation number 18, we get the a more tractable form of the equation. Y is equal to gamma into alpha a bar is autonomous expenditure, plus gamma into b by h upon m bar upon p. And then if we if we substitute beta as gamma b by h, then in the second term we can replace it with beta. Now this all reduces in equation number 19 to a much simpler form. Y is equal to gamma a bar plus beta m bar by p. So we come back to our original statement that on the left hand side we have aggregate supply or output, and on the right hand side we have gamma, which is a parameter, kind of a multiplier, into a bar, which is autonomous expenditure, plus beta into m bar upon p, which is nothing but the supply of real cash balances or money supply. If we transform this equation, we arrive at the aggregate demand function. Here the price level is taken onto the left hand side. Now this is the form of the aggregate demand function which we desire. The price level P is equal to beta into whole bracket m bar upon y minus gamma a bar. So this is our equation number 20, which is the aggregate demand. Now gamma is the fiscal policy multiplier, beta is the monetary policy multiplier, given the fact that there is A bar which is exogenous spending and nominal money supply M bar, these are given. Then what we can say is that P is inversely related to the level of output, which is the main property of the aggregate demand function. Under general equilibrium, we have obtained through the intersection of IS and LM each point of the aggregate demand function where the IS is equal to the LM is equal to intersects with the LM function. The aggregate demand function we can see is not linear because there is this inverse relationship which makes it non-linear. The price level changes therefore are proportionate to the change in money supply, and the aggregate demand function, these are some more properties. The aggregate demand function would be flatter if the interest responsiveness of demand for money H is smaller, if the interest responsiveness of investment B is larger, if the multiplier gamma G, that is government expenditure multiplier, is larger, and if the income responsiveness of money demand K is smaller. These are all the properties of the aggregate demand function. Now, let us examine the demand management. In the case of classical theory, money demand is irresponsive to the interest rate. So, according to quantity theory of money, there is equilibrium in the money market when the supply of real cash balances is equal to the demand for real cash balances, and this is given by the Fisher's equation, which is MV is equal to PT. M we know is the stock of money, V is the velocity of circulation of money, P is the price level, and T is the volume of transaction. There are two types of velocity of circulation of money. Please remember, one is the transactions velocity of circulation of money and the other is the income velocity of circulation of money. In the Cambridge equation, it is allowed that people could hold money, and therefore we have another form of the quantity theory of money equation, the QTM equation, and that is M is equal to small k into P, which is the price level, into small y. Y is the real output or real income, and K is the proportion of money held as a cash balance, and this would be the inverse of the velocity, income velocity of circulation of money. Therefore, K would be equal to 1 upon V, V which is the income velocity of circulation of money. Y is the real output, small y is the real output. Therefore, if we consider equilibrium in the money market, then M by P which is the supply of real cash balances would be equal to the demand for real cash balances, which is 1 upon V times Y, which is the real output. So, if we examine the classical case, then the LM function would be vertical because only one equilibrium level of income exists, and that is the full employment level. And whatever be the price level, the equilibrium level of income would remain the same. Therefore, the relationship between income and rate of interest is irrelevant in this case. The supply of cash balances may increase, but the income and output would be insensitive, and whatever cash balances are additional cash balances are there in the economy, they would simply be absorbed, and therefore what we see is that we have an LM function which is vertical. In the case, now let us consider fiscal policy and monetary policy. There would be an initial level of IS and LM corresponding to the given nominal money supply and the given price level, and there is a point of equilibrium E, and it corresponds to the aggregate demand function that is given. Now suppose the government expenditure increases, let us say on infrastructure or any other thing, health, education. As a consequence, the IS schedule would move outwards to the right. You are aware about this. At the initial price level, there would be equilibrium at E prime with a higher rate of interest and a higher level of income and spending. Thus, the initial level of P0, at P0, the income level and the spending are higher, and at the new level E prime, the new aggregate demand function reflects the impact of higher level of spending. The aggregate demand function shifts to the right by an amount which is indicated by the fiscal policy multiplier gamma, which appears in the denominator of our money demand function. But with between the price level and the real output, the relationship, as we know, is negative. Because of this relationship, there is a proportional shift in the aggregate demand, and they would not be exactly parallel. So we have this situation that the original equation is between LM and IS, and they are equal at point E. The rate of interest is R1 and the level of income is Y0. Then the IS function shifts to the right, I prime S prime, and this is because of additional government expenditure. The new equilibrium is E prime. At E prime, the rate of interest is R0 and the level of income is Y1. If we look at the fifth quadrant as we have derived it in the beginning, and we extend the Y0 and Y1 levels of output by the dotted line into the fifth quadrant, where we would notice that there is one aggregate demand function AD, this is the original aggregate demand function, and at point E it shows that the price level, the given price level is P0, and at this point the level of output is Y0. When the aggregate demand function shifts to the right, it becomes AD, A prime, D prime, and the new equilibrium would be established at E prime. And so what is, if we consider that the price level is this to be the same, then what would happen is that there would be excess demand, that is E prime would be the excess demand. But then if we consider a new aggregate demand function at the new price level, then the price level would go up for the same given level of output, which is Y0. So in this way, what we see is that with expansionary policies, if the government expenditure increases, aggregate demand does increase, the level of output does increase, but this has an implication for the price level as well. This is the implication of fiscal policy. In terms of monetary policy, once again we look at the IS and the LM functions. The IS Now, in summary, what we can say is that in an ordinary market situation, the demand and supply functions are different from a macro aggregate demand function. The macro aggregate demand function is sensitive to the general price level in the economy. And then we have seen how we can derive the aggregate demand function in the economy. The aggregate demand function, the modern macro aggregate demand function in the economy is based on the intersection of the IS and LM functions in the economy. That means each point on the aggregate demand function represents general equilibrium in the economy. There is a corresponding level of rate of interest, equilibrium rate of interest, and an equilibrium level of income in the economy. According to this, we have derived graphically with the use of the 4-quadrant diagram and an additional diagram which represents the 5th quadrant. We have shown that at different points of equilibrium in the economy, how we have a downward sloping aggregate demand function which gives the relationship between general price level and output in the economy. Then we have seen how through a chain of algebraic derivations, how we have arrived at the aggregate demand function which shows an inverse relationship between the price level and output. And we have also seen that the aggregate demand function is sensitive to a large number of parameters in terms of investment, rate of interest, and so on. And then we have seen how the shape of the aggregate demand function could be flatter or steeper depending on these parameters. The slope also we have seen is negative, and with all of this we have had then moved on to the demand management. In demand management, we have seen how the impact of additional government expenditure or fiscal policy affects the economy, and how monetary policy through an expansion of money supply also affects the economy. The difference is that now when we are talking about aggregate demand, then it is sensitive to the price level, and therefore policies are such that they are able to take account of the inflation and the changes in the price level, unlike the Keynesian economy where the aggregate demand and in fact aggregate supply were both insensitive to changes in the price levels.